We live in a very unusual world, marked by great and irreversible changes that occur within the span of one man's life. We live in a time where our knowledge and understanding of the world of nature grows wider, broader, and deeper, with unparalleled speed and scope, and where the problems of applying this knowledge to man's needs and man's hopes are very new and only a little illuminated by our past history. In traditional societies, it has always been the great function of culture to keep things rather stable and quiet and unchanging. It has been the function of tradition to assimilate one epoch to another, one episode to another, one year to another. It has been the function of culture to bring out meaning precisely by pointing to the constant traits in our life, which in easier days one talked about as the eternal verities, and to let the meaning shine from the fact that some things could be counted on to be there, to be steady, in spite of the great flux with which nature surrounds us. In the most primitive societies, if we believe our anthropologists, the principal function of ritual and religion, of culture as it is practiced, is in fact almost to stop change. It is to provide for the social organism what life provides in such a magic way for living organisms, a kind of homeostasis, an ability to remain intact, to respond very little to convulsions and alterations in the world around. Now today, culture and tradition have assumed a very different intellectual and social purpose. I will be coming back to this throughout the talk. The principal function of the most vital and living traditions today is precisely to provide the instruments of very rapid change. There are many things which go together to bring about this alteration in our life, but probably the decisive one is science itself. I use that word as broadly as I know, meaning the natural sciences, meaning the historical sciences, meaning all those matters on which we can converse with each other with a certain objectivity. I shan't harp on the distinction between science as an effort to understand the world, to find out about it, on the one hand, and science in its application in technology as an effort to do something we hope useful with the knowledge so acquired. But a certain care is called for. If we call this the scientific age, we make this a little too simple. On the one hand, a great deal has come along with the scientific age, culturally, practically, technically, economically, spiritually. These have been concomitants in our history, but are perhaps not inevitable. You see this when you see the rapid growth of science in a country to which it's not indigenous. Japan may be an example. And for another, when we talk about science today, we are likely to have relatively fixed stereotypes. The biologist with his microscope, the physicist with his cyclotron. But almost surely a great deal that is not now subject of successful study in science will later come to be. I think we probably today have under cultivation only a very small part of the terrain which will be natural for the sciences a century from now. I think of the fantastic growth of fundamental biology. I think of the fact that man is a part of nature, and as a part of nature, not uninteresting and very open to study. This is for the future. I stress, in a sense that I will come back to, any subject on which the ambiguity of communication presents no real problems has the characteristic of a science. And the reason for this great change from a slowly moving, almost static world to the world we live in is the cumulative character, the firmness and givenness of what has been learned about nature. It is true that it can be transcended when one gets into a new part of the experience of the natural world. What is true on the scale of an inch isn't necessarily true on the scale of hundreds of billions of light years. But what we find remains true and proven and fixed, so that everything that's found is added to what was known before, enriches it, does not have to be done over again. One has an essentially cumulative, irreversible character of learning things, and this is a hallmark of science. There isn't anything irreversible about art. It won't go away, but it's not primarily there as something for others to build upon. It's primarily there for enjoyment, insight, understanding. It is this irreversible character which means that in man's history, the sciences make changes which cannot be wished away and cannot be undone. I'll give two examples, very different ones. There's much talk, has been for 15 years, about getting rid of atomic weapons. I, like all people, have a deep sympathy with that talk. But we mustn't fool ourselves. The world is not going to be the same no matter what we do with atomic bombs, because the knowledge of how to make them cannot be exorcised. It is there, and all our arrangements for living in a new age must bear in mind its omnipresent virtual presence and the fact that one cannot change that. A different example goes back 5 centuries more. We can never have again the delusions about the centrality and importance of our physical habitat, now that we know something of where the Earth is in the solar system and know that there are hundreds of billions of suns in our galaxy and hundreds of billions of galaxies at least within the reach of the great telescopes of the world. We can never again make the dignity of man's life have anything whatever to do with the special character in space and time and mechanics of the place where we happen to live. These are irreversible changes. So it is that the cumulative character, the irreversibility of the growth of the sciences, give a paradigm, an example of something which is in other respects very much more subject to question, the very idea of human progress. One cannot doubt that in the sciences, the only direction of growth is progress. One learns more. One may learn that one's made a mistake, but that is to learn more. This is true of knowledge of fact, of understanding, knowledge of skill. When one implies this example, though, to the human situation and complains that we have made great progress in automation, in space research, and so on, but no comparable moral progress, this involves, to my mind, a total misunderstanding of the analogies between the two kinds of progress. I do not mean that moral progress is impossible, but it is not in any sense automatic. Moral regress is just as possible. We have seen too many examples in our own century. Scientific regress is not really compatible with the continued practice of science. What I want to do in this hour is not at all pretentious. I want to discuss some points on the nature of science and its interrelations with culture. It is my hope that talking of these questions may give a little ground for further discussion. I don't have simplest views. I can't subscribe to the view that science and culture are coextensive, that they are the same thing with different names. And I cannot subscribe at all to the view that science is something useful, but essentially unrelated to culture. I think indeed that we live in a time which has few historical parallels that there are practical problems, problems of the restructuring of human institutions, of their obsolescence and inadequacy, and problems of the mind and spirit, which, if not more difficult than ever before, are different and are indeed plenty difficult. I'll run over the themes that I'm going to touch on. The first is the question of why the scientific revolution happened where and when it did. The second, the pattern of growth of the sciences. The third, their internal structure. The fourth, the relation of discovery in the sciences to our general ideas in matters which are not closely related, obviously related to the sciences. And the next with the question of freedom and necessity in the sciences, the question of the creative and open character of science, its infinite character, if you want. And the last has to do with what direction these various points suggest for us in trying to bring coherence and order to our cultural life, in doing what it is right and necessary for a group of intellectuals, artists, teachers, scientists, philosophers, statesmen, lawyers, to do to help refashion the institutions of this world as they indeed need refashioning if we're even to survive. It is not a simple question to answer why the scientific revolution occurred when it did. I think all serious historians would agree that it started in the late Middle Ages, the early Renaissance. It was very slow. Now, no great culture has been free of curiosity, of reflection, of contemplation. To know the causes of things is something that serious men have always wanted, in a quest that serious societies have always sustained. No great culture has been free of inventive genius. If we think of the culture of Greece or the following Hellenistic period, it is, to me, quite puzzling that the scientific revolution did not occur then. The Greeks discovered something without which science would not be possible. Something that is foreign to Chinese culture, foreign to Indian culture. This is the notion of rigor, the idea of proof, the idea of logical necessity, that one thing implies another. Without that, of course, science is essentially impossible, because the trick of science, of the sciences, is to find out mistakes. And unless there is a quasi-rigid structure of implication, then if something turns out unexpected, you have no way of knowing where to look for the mistake. You have no way to correct yourself. But the Greeks discovered this very early and codified it very early in their history. They were a curious people. They were inventive. They didn't experiment on the scale of the University of Colorado, but they experimented very, very brilliantly. And they had, and this is something that is only recently appreciated, a very high degree of technological sophistication. They could make very complicated and subtle machines and instruments. And they did. They didn't write much about this. We find out about it only by recovering the instruments. They did not make a scientific revolution. Perhaps this was because their communication was not adequate. For us, this is the central point. But it seems very good. They were a small society. They talked freely with one another. The record of these talks is as good reading, even today, as anything that's ever been written. I believe that the answer lies elsewhere. In a matter of history, of course, to assign a cause is not a very rigorous thing, because nothing ever happens twice. I think that the best guess is that the scientific revolution took, in addition to what the Greek intelligence contributed, an element that is also not present in Chinese culture and is wholly absent in all the forms of Indian culture. It took precisely an idea of progress, not the Greek idea of progress in understanding, but of progress which has to do with the human condition. Progress as is well expressed in the second half of the famous Christian dichotomy, faith and works. The notion that the betterment of man's condition and his civility have deep meaning, and that we all have a responsibility and a duty to it, to history and to man. This is, of course, an Old Testament idea, and its rediscovery in the Renaissance and its resonance in the Protestant faiths seems to me a very essential condition for what has happened since. This, and of course, the rediscovery of the classic world, of Greek science, mathematics, and philosophy. It was all quite slow in the giant days of Kepler and Newton. But by the 17th century, there were enough men involved so that in all the deeply civilized countries of Europe, and then in this country, societies were formed, academies, to bring men together for the promotion of useful knowledge in this country, for the study of nature, the discovery of new knowledge in England, the Academy in France. They could talk to one another and bring to the prosecution of the sciences that indispensable element of working together, of correcting one another's errors and admiring and being grateful for other people's skills that characterize these parts of human life and are their true hallmark. These scientific communities were celebrated in the Enlightenment of the 18th century, and in this we see the first explicit articulation of a harmony between the sciences, the notion of human progress, the spirit of fraternity among men, an unending increase in knowledge. You find it all in the words of Franklin, even more, with a certain superficiality but very great beauty. Just before Newton, Hobbes wrote, "The sciences are small power." And he said the reason was that nobody could understand them except the men who did it. A century later, the encyclopedists were saying just the opposite and basing their hopes for the freedom of man, freedom from tyranny and freedom from superstition, on the progress of science. This context in which the sciences were born has largely accompanied them. Science was born in a context of fraternity and even of a universal brotherhood. It has encouraged a political view, ours, which is egalitarian, permissive, pluralistic, and liberal, everything for which the word democratic is rightly used. And the result is that the scientific world of today is not only a very technical one, and not only one of very rapid growth of knowledge, it's also an awfully large one, an open world, which, of course, not everybody does everything, in which not everybody is a scientist or a secretary of state, but in which we fight very hard and rightly against inappropriate arbitrary exclusions of people from any works or discourse or position for which their talents and their interests may suit them. Thus, we face our new problems created by the practical consequences of technology and the vast intellectual consequences of science itself in the context of a world of 2 or 3 billion people, in the context of an enormous society, in a context of a society for which none of our institutions were ever really designed. We are facing a world in which growth is characteristic, not just of the sciences themselves, but of the economy, of technology, the spread of institutions. You can't look at a paper, not one day, not even in Boulder, without knowing all about it. I've spoken of the growth of science, noticing that it started slowly. And as I've said, there are many sciences still to come, hardly born. But from the 13th century to the 20th is a long time, and the growth has been spectacular. One can measure it in a number of ways. I don't mean a growth in quality. The excellence of scientists hasn't gotten any greater. His knowledge, his power does, but not his quality. There isn't anybody better than Newton, or for that matter, Kepler, just as there is no playwright better than Sophocles, and no gospel greater than St. Matthew or the Bhagavad Gita. But something has happened, and that can be measured, and that's been done. One can measure how many people work on scientific questions. One can count them. One can notice how much is published. These two criteria show a doubling of scientific knowledge about in every 10 years. I have one friend who calculated that one journal, an American journal for fundamental physics, one of many we publish here, one of dozens that are published throughout the world, that if it continues to grow as rapidly as it has in the last 15 years, next century it'll weigh more than the Earth. It's not only funny. In 15 years, the volume of chemical abstracts has quadrupled. I think that molecular biologists say that in 5 years, more has been learned about the nature of life than in all human history. If you talk about scientists today and mean by that people who devote their lives to the acquisition of new knowledge or to its direct application, about 93% of us are still alive. This enormously rapid growth, which has been sustained, not uniformly in the various sciences, for about 2 centuries, means, of course, that no man learned today, as a boy or a youth, more than a small fraction of what he ought to know in his own field. Now, there are a few points to worry about. One is the natural reaction that most of what is published is trivial. It, I'm afraid, isn't so. We are, after all, self-serving people, and we wouldn't force ourselves to read through masses of things if there were any way to avoid it. We don't publish things that we can get along without. And the second is a deeper point, and that is that very often new things make it possible to forget some of the old. If you find a general law, you don't need to remember all the instances that were compiled before. And there is truth to that. Any great new understanding, any great element of order that's discovered, does, to some extent, clear the slate of past knowledge. But this is opposed by the tendency to explore more widely in newer and more remote fields, remote simply from ordinary human experience, maybe remote in space or time. And one can't, in general, forget too much of the past of a science, because it is not only the means whereby new discoveries are made, it is, in a logical sense, the means by which the meaning of the new discoveries is to be explained and made concrete. It is the tradition of a science which gives us the instruments in terms of which new things are found, both in physical terms and in terms of ideas and in terms even of language. It is the strength of the scientific traditions that they provide this forward thrust. A third point, of course, is that the growth I've described will not, just as a mathematical rule, continue indefinitely. And we think that there will be some kind of saturation in which things don't double every year, but at a point at which the acquisition of new knowledge is very much greater than it is today. Not everybody will be a scientist. There will still be some vice presidents, some lawyers, here and there a farmer. This raises, I think, a rather serious question. In a quite clear and practical way, a man who is interested in using his mind and learning will have a choice. Obviously, he will try to compromise. On the one hand, if he's a professional, he may continue to learn about his own field in a hard, intimate, detailed way, knowing it as a craftsman. Then the field will not be very wide. His knowledge will be partial, but it'll be intimate and deep. Or he may, on the other hand, say that he will try to learn broadly and therefore probably superficially about what goes on in a wide area of science, in many of the sciences, but then he won't be competent and he won't master it and he won't have this intimacy and depth. The reason I emphasize this is that contrary to the general view, the cultural values of the life of science do not lie in the broad synopsis. They lie precisely in the intimate, workmanlike view. Here are the hard lessons, the real choices, the great disappointments and astonishments and discoveries are clear and detailed. And this is where science is most human and where its analogies with the arts are most deep. The structure of the sciences can't be very simple in this situation. It isn't just that everything is related to everything with a great intimacy. All of the sciences grow out of common sense. They grow from curiosity, observation, reflection, and then the refinement of observation, the refinement of analysis. And by exploring and pushing things a little further than in ordinary life, making them a little more extreme and abstract. And in this novelty, then, there are usually surprises for us. We have to talk differently about what we find. We find opportunities for exploration, as with the telescope, which simply could not be imagined within the framework of a completely non-technical life. The old ways of talking get so cumbersome and inappropriate that we make a big change and one recreates one's whole way of describing this part of nature. And in all of this, we follow the rule that we are prepared to say just what we've done and what we've found, and be patient and wait for others to look and see that they find the same things, to reduce to the point where it makes no real difference the normally overpoweringly vital element of ambiguity in the way we talk about things. We all live by being ambiguous, by not settling things because they don't yet have to be settled, by suggesting more than one thing because their co-presence in the mind is a source of beauty and resonance. But in talking about science, one can be ambiguous, of course, but not when one comes to the clinches. Then we must be completely clear and straight and without any doubt that what we say is what the other man understands. He must be schooled to understand it, but that's what we come to school for. And we tell him what we found and how we did it. And if he doesn't understand us, we may visit him and try to help. If he still doesn't understand us, we go back home and see if we made a mistake. And out of this, there comes this firmness and solidity, which is the the miracle of the world of the sciences. Well, how does it go? In studying the different parts of nature, one explores with different instruments, and one gets a kind of branching of the tools, of the ideas, and of the words, so that what was our own common sense and our own common talk develops into specialized and different ways of dealing with the different aspects of nature. This tree-like structure, all growing from the common trunk of our common life together, has branches which correspond to different kinds of questions, different kinds of ways of asking nature, different ways of talking about nature. And the unity of science, apart from the fact that it has this common origin in our life together, is not at all a unity that one part of it derives from another, or one part of it implies another, or that one part of it is logically identical with another. That is occasionally, but rarely so, that there is some way of making a correspondence, or a unique correspondence between genetics or topology, to take an unlikely example where there is indeed a small connection. The unity of science consists of two things. First, and in ever more impressively, an absence of inconsistency. We talk of life in terms of purpose and adaptation and function, and it's hard not to talk so. But you will find in life no tricks played on the laws of physics and chemistry. These laws will not give you very much useful and interesting insight into the great problems of living things, but they will apply. In the past, I should say. In the past, there has been no indication that anything we find in one part of nature is out of harmony with what we find in others. But it may, of course, involve a different set of preoccupations. It must. And the contrast between the kind of questions we ask of a living organism and the kind of questions we ask about a developing galaxy will illustrate this. Very often between two different branches, we find a sharp, important mutual relevance. They throw light on each other. Sometimes, and it's one of the great moments, things that have happened in different parts of science turn out to be parts of an even greater overarching discovery. But the image that I have is not one of an array of laws and facts, each following from something more deep and fundamental, but rather a living thing, a tree, if you will, but a tree that does have this unlikely habit that the branches touch and then grow apart again. It's a sort of network. The knowledge that is being increased in this extraordinary way is therefore inherently, rightly, very specialized. It is the specialization of science that gives it its thrust. It's different for physicists, astronomers, the different kinds of biologists, mathematicians. There is this important mutual relevance. But even in physics, where we fight very hard to keep the different parts of our subject from flying apart, would like to make it so that physicists can always talk to each other and understand, we don't entirely succeed, in spite of a passion for unity that is very strong. The traditions of the sciences are specialized, and that is their strength, that they use just the words, the machinery, the concepts, the theories, the instruments that fit their subjects. They're not encumbered by having to try to fit other sorts of things. It is the specialized traditions to which we owe it all. And this is, of course, one of the things that makes the very great problem of our time, the problem of teaching, of explaining the sciences. when we get something powerful and general, a great law of nature, then just by virtue of the fact that it's in the logical sense very general and encompasses a vast range of experience, just then, in the words we use and the ideas they represent, it is most specialized and really, without preparation and care, quite unintelligible to anyone but a specialist. The great laws of physics today, they don't describe the whole physical world, or we'd be out of business, but they describe everything that an ordinary man notices about the physical world without fantastically impudent instrumentation. These great laws cannot be formulated in terms that can be reasonably defined without a long period of schooling. It's not quite so true in newer subjects, but comparably. And these specialized communities that know their onions, these guilds, if you want, they're a very moving experience for those who participate. There have been many temptations to build something in analogy to them in other human activities. A simple analogy, one that has been talked a great deal, is this. If biologists or astronomers or physicists can work together so effectively across national boundaries in countries with different cultures, different politics, different religions, even in countries with great hostility, is this not a way to bring the world together? It certainly is one of the few things we know how to do. We are doing a little of it. We should certainly do all of it we can to promote international collaboration of the most intimate and direct kind. But it is, of course, a very fragile and limited way to bring the world together. And I will turn a little later to a generalization that may be called for by these times. Another point is that the patterns, the habits of the sciences have to some extent, because the way universities work, also been applied to philosophy, to other branches of learning, to the arts. What one calls technical philosophy, which is philosophy as a craft, philosophy for other philosophers, and art for artists and critics. I think that these are profound misreadings and even subversions of the true functions of philosophy and art, which are not, in my opinion, addressed to specialists, which are should address themselves to the general common human problem, to man, not of course to everybody, but to anybody. It is clear that if there's any truth at all to what I've been saying, we are faced with a formidable problem of communication, of telling people about things, and of teaching. I don't think there's any escaping this. I think that it's a job which will occupy a greater and greater part in human life, an immense job, never ending, never done, teaching on all levels, in every sense of the word. I think also it's one of the noblest of human efforts. It's often been said that great discoveries in science, when they come into the lives of men, affect their attitudes toward man's place in life, man's views, his philosophy. And there is surely some truth in it. We're all taught how it was with Newton and with Darwin. But it's a little tricky. Newton is not a very good example, for when we look closely, we're struck by the fact that in the sense of the Enlightenment, the sense of a coupling of faith in scientific progress and of man's reason with a belief in political progress and the secularization of human life, Newton himself was in no sense at all a Newtonian. His successors were. There are, I think, 2 points. First, if discoveries in science are to have an honest effect on human thought and culture, they have to be understandable. That is likely to be true in the early periods of science, and only in the early periods of science, when it is talking about things which are not too remote from our ordinary experience. Some of the great discoveries in this century go under the name of relativity and uncertainty. And I think when most people hear these words, they think that's how I felt this morning. I was relatively confused and quite uncertain. You really need to go to school to know what these words, tortured out of all relation to the common use of the words, means. What they really mean. I think the reason why Darwin's discovery, or rather perhaps his great and open hypotheses, had such a great impact was in part because it was really a very simple thing in terms of ordinary life. We can't talk about what's going on in biology today in ordinary language, but he could. And I think that the great effects of the sciences in stimulating and enriching philosophical life and cultural interest are typically confined to the rather early times in the development of the science. But then there's another requirement. I think that's a necessary one, but not sufficient. I think that discoveries only really resonate and change the thinking caps of men when another condition is satisfied, when the discoveries feed some hope, some need that pre-exists in the society. The real sources of the Enlightenment they were fed, of course, by the scientific events of the time, came really in the rediscovery of the classics, perhaps primarily in the classical political theory and in the Stoa. But I think that the hunger of the 18th century to believe in the power of reason, to throw off authority, to wish for a secular culture, to take an optimistic view of man's condition, these caused men to seize on Newton and his discoveries as an illustration of something already deeply believed quite apart from the law of gravity or the laws of motion. And the hunger with which the 19th century seized on Darwin had very much to do with the increasing awareness of history and change, with a great desire to naturalize man, to put him in the world of nature, which pre-existed long before Darwin and made him welcome. I have seen an example in this century where Niels Bohr, the great Danish physicist, found in the quantum theory, when it was developed 30 years ago, this remarkable trait. It's consistent with describing an atomic system much less completely than we are used to describing large-scale objects. We have a certain choice in which traits of the atomic system we wish to study and measure and which to let go, but we don't have the option of doing all of them. This situation, which we all recognize as familiar in human life, excited in Bohr his old view of the human condition, that there are mutually exclusive ways of using our words, our minds, our spirits, any one of which is open to us, but which cannot be combined. Ways as different, for instance, as preparing to act and entering into an introspective search for the reasons for action. This discovery has not, I think, the discovery in physics, penetrated into our life and our culture. I wish that it had. It is a very good example of something that would be deeply relevant to our attitude toward things if it could only be understood. Einstein once said that a physical theory was not really determined by the facts of nature, but was a free invention of the human mind. This raises the question, how necessary is the content of science? How much is it something that we are free not to find? How much is it something that could be otherwise? This, of course, is rather an essential point in asking how we may use the word objectivity, or even the word truth. Do we, when we find something, invent it or discover it? Well, it's just what you would guess. We are, not individually, but in our tradition and in our practice, and with men of genius also as individuals, free to decide where to look at nature, how to look at nature, what questions to put, with what interests and with what purpose. But we're not the least bit free to settle what we see. Men must certainly be free to invent the idea of mass, as Newton did, and as has been worked on by the schoolmen ever since. But having done so, there are some things we're not free to find, that the mass that determines the inertia of a body and that determines its gravitational field are different, or that the light quantum or the neutrino have any mass other than zero. Men were free to discover and invent the idea of an electric charge, but having invented it, we have to notice that all of the more or less elementary particles in nature that we know today have either the charge of the electron or its negative or zero charge, nothing else. So it is, we're free to start things, free to go about them, but then the rock of what the world is really like limits and shapes this freedom. That is why the ontological interpretations of the word objective don't seem very useful, and why we increasingly use it, not ontologically, but to describe the clarity and the lack of ambiguity, and thus the effectiveness of the way we can tell each other about what we have discovered. From all of this, it's fairly clear that in the sciences, total statements that bravely use the word all with no qualifications, are not very likely to occur. In every investigation, in every extension of knowledge, we're involved in action. And in every action, we're involved in choice. And in every choice, we're involved in a kind of loss, the loss of what we didn't do. You find this in the simplest situations. You find it in perception, where the possibility of perceiving is coextensive with ignoring many things that are going on. You find it in speech, where the possibility of understandable speech lies in your paying no attention to the tremendous miscellaneous racket that I'm making and hearing the words. Meaning is always attained at the cost of leaving things out. One finds it in action, and it's of course a recurring theme of the arts and of literature. And one finds it in the idea of complementarity, this trait of atomic physics, where it is formally recognized that the attempt to make one sort of observation forecloses and ruins the attempt to make another. We have freedom of choice, but we have no escape from the fact that when we act, we also fail to act. In practical terms, this means, of course, that our knowledge is finite and never all-encompassing, and there is always much that we necessarily miss at the cost of perceiving and knowing. There is always much that we cannot get hold of because the very act of learning and ordering and finding unity and meaning, the very power to talk about things, means that we leave out a great deal. Now, I don't mean this mystically, but factually and indeed very modestly. There is every reason to take pride in all that's been learned about nature, and a little bit, not much, about ourselves. But there is a good deal of reason to remember that this is always done at the cost of losing information which was there to be had. Ask the question, would another civilization, based on life on another planet not too unlike ours, in its ability to sustain life, would it have the same physics? I have no idea whether it would have the same physics or not. It wouldn't find other answers for the same questions. There wouldn't be any irresolvable contradictions, but they might just be talking about very different subjects. This makes of ours an open world, a world without end. I had a friend in Berkeley, a Sanskritist, who used to say to me, make me uncomfortable, that if science were really any good, it should be much easier today to be an educated man than it had been a generation ago. That's because he thought the world is closed, but it's open. The things that make us choose one set of questions, one branch of inquiry rather than another, are, of course, embodied in the scientific traditions. In the developed sciences, each man has a limited sense of freedom to shape or alter them, but they are certainly not determined wholly by the findings of science. They are largely of an aesthetic character, and the words we use, simplicity, elegance, beauty, indicate that what we are groping for is not only more knowledge, but knowledge that has order and harmony in it. And of course, like everybody else in this world, we hope for continuity with the past. We want to find new things, but something that's not too new. It's when we fail in this great hope that the really great things happen. I should, of course, say what is obvious, that the fact that something is simple, elegant, beautiful, and only moderately new does not mean that it's true. That's another matter. Now, all these points, the origins of science, scientific age, its growth pattern, its branching reticular structure, its increasing alienation from the common understanding of man and from philosophical questions, its freedom, the character of its objectivity, its openness, are somehow relevant to the relations of science and culture. I'm not here talking about the popular subject of mass culture. In talking of that, I think it's right to be critical, but I believe above all that we should be quite human, not a snob, and rather tolerant and rather loving. This is a new problem, and it's not going to be arranged by the methods of Periclean Athens. I do think that in the problems of the mass culture, and above all of the mass media, it's not primarily a question of the absence of excellence. The worker today in Paris or Tokyo or Denver has within reach probably better music, more good art, more good writing than his predecessors ever had. If there is trouble, it seems rather that the good things are lost in the stream of rather poor things. The noise level is terribly high. Some of the conditions for appreciating excellence aren't present. I don't think we eat very well unless there's a certain hunger, and good cooking involves a certain frugality. And there is something wrong with the mass media along these lines. But that's not what I'm after. Rather, I think loosely of what we may call the intellectual community. Artists, statesmen, many professions, prophets, scientists, artists. It's an open group, not sharply separated, and some people think they're in it now, some people don't think they're in it now. And it's a growing group, and it's a growing fraction of all people. And as the world catches up with its desperate problems of poverty and doesn't blow itself up, this will go on all over the world. In it is vested the great duty for enlarging, preserving, and transmitting our knowledge, our skills, our understanding of interrelations, of priorities, commitments, ethical injunctions, meanings, to help men deal with their joys and sorrows, with their finiteness and their beauty. Some of this has to do, as the sciences so largely do, with propositional truth, with propositions which say, if you do so and so, then you will see, which have the kind of objectivity that enables them to be checked and cross-checked until, though it's always wise to be open to doubt, there are really good ways to put an end to doubt. This is the way it is with the sciences. It's not all there is to the sciences because they are human and involve a sense of form and a sense of history. In this intellectual community, there are other kinds of statements, not proposition, which emphasize a theme rather than stating a fact. They may be statements of connectedness or relatedness or importance, or they may be in one way or another statements of commitment, committing oneself, or expressing an agreed commitment of a group or a society. To them, the word certitude, which is a natural ideal for the sciences, is not very sensible. Depth, firmness, universality, maybe other things, but certitude, which is a characteristic of verification, is not the great criterion of much of the work of a philosopher or a painter or a poet. For these things are not, as I have outlined, objective. Yet for any true community, for any society worthy of the name, they must have an element of community, of being common, of being public, of being relevant and meaningful to man, not necessarily to everybody, but to man and not to a collection of specialists. I have been much concerned that in this world of change and scientific growth, we have so largely lost the ability to talk with one another. In the great succession of deep discoveries, we have become removed from one another in our traditions, even a little in language. We have had neither the time, nor the ruggedness, nor the skill to tell one another why we have learned, nor to listen properly, nor to see what there was that would increase and enrich our common culture and understanding. And so it is that the public sector of our lives, what we hold and have in common, has suffered, as have the illumination of the arts and the deepening of justice and virtue, and even the ennobling of power and of the quality of our common discourse. We are much less men for this. Never in man's history have the specialized traditions flourished more than today, and we have our private beauties. But in those high undertakings where man derives strength and insight from public excellence, we are impoverished. We hunger for nobility, the rare words that are the rare acts that harmonize simplicity with truth. In this default, I see some deep connection with the great unresolved public problems: survival, liberty, and fraternity. In this default, I see also the responsibility that our community, the intellectual community, has to history and to our fellows, a responsibility which is a necessary condition for remaking human institutions as they need to be remade today, that there may be peace and that they may bear more fully those ethical commitments without which men cannot properly live as men. This may mean for the intellectual community a very much greater effort than in the past. The community will grow, but I think also that the quality and the excellence of what we do must grow. I think, in fact, that with our growing wealth, and in the end the growing wealth of the world, and the possibility that not all of it will be used to establish committees, there may indeed be some leisure, and that a high commitment on this leisure is that we reknit the discourse and the understanding between the members of the intellectual world. In this, I think we have, probably all of us, to preserve our competence in our own professions, or even parts of professions, to preserve what we know intimately, to preserve our mastery. This is, in fact, our only anchor in honesty. We need also to be open to other and complementary activities, not intimidated by them, not contemptuous of them, as today so many are, of the natural sciences and the mathematical sciences. And as a very start, we must learn again, without contempt and with great patience, to talk to one another, and we must learn to hear.